Hello, my name is Scott Neves, and I'm the lead design engineer at Fathom5, a service-disabled veteran-owned small business based in Austin, Texas. Today I am here to talk about Tesar Power, a patented gear train technology that is fundamentally changing what's possible with electromechanical actuators in high-force naval applications. This brief will cover who Fathom5 is and what we do, the specific Navy challenge we were asked to solve, what Tesar Power is, and where we are in development, and the transition pathway we're pursuing to get this technology to the fleet. If you build, procure, or maintain actuators for naval platforms or shipboard equipment, I'd especially encourage you to connect with us afterwards, because Tesar Power may be the electromechanical solution you've been looking for. Fathom5 was founded to solve the gap between the pace of commercial technology innovation and what was being fielded on Navy platforms. We have 14 active defense innovation contracts and a portfolio of 17 patents, including the 7 patents that form the foundation of Tesar Power. Tesar Power represents our deep investment in mechanical innovation, and it's the most significant hardware technology in our portfolio today. In Topic N231-053, Improved Electromechanical Actuators for Aircraft Carrier Flight Deck Applications, NAVC requested proposals to reconfigure the Ford-class Jet Blast Deflector Actuation System to improve JBD lowering times during mechanical or electrical failure of the system's electromechanical actuators without sacrificing system, vessel, or personnel safety. Ford JBD number 3 prevents aircraft landing operations if the EMAs fail in such a way that the JBD is jammed in the deployed position. Current vessels of the Ford class use a complex hydraulic emergency system to decouple the JBD panels from malfunctioning EMAs and safely lower the panels to their stowed position. The 12-minute limit for emergency lowering of all JBD panels during an EMA failure is close to the cycle time of the in-service emergency lowering system. Additionally, the emergency lowering system reintroduces hydraulics into the JBD operational equipment. The nature of the existing lowering system requires multiple personnel to operate and is complex due to the remote hydraulic power and control unit. Tesar Power is a state-of-the-art high-torque eccentric drive using non-involute, non-cycloidal discs to achieve lower tooth contact stress and higher tooth contact ratios, allowing heavier loading and longer life compared to typical cycloidal drives. A Tesar Power eccentric typically constitutes the output stage of an actuator using an electric prime mover. Key U.S. patents protect the various machine configurations using the proprietary gear trains invented in those patents. The range of Tesar Power gear train configurations yields a wide array of actuator configurations to meet many high-force actuator applications. Proper electric motor, reduction ratio, and output linkage selection allows the design of actuator outputs with the force, size, and range of motion required to replace many hydraulic actuators. Parts for the subscale prototype designed for N231-053 Phase 2 base are currently being manufactured for technology demonstrator tests in Q1 of 2026. Once subscale parts arrive, the first article Tesar Power prototype will be assembled and integrated into a commercial truck liftgate, replacing the hydraulic actuator. A commercial liftgate was selected as the testbed for the technology demonstrator to reinforce the broad potential market for Tesar Power actuators in industrial applications as well as those in the military. Design of the integrated JBD lowering actuator for N231-053 Phase 2 Option 1 has commenced and is nearing conceptual design review readiness. Recently, Fathom5 has been awarded a sequential Phase 2 contract for Catapult Challenge Topic N254-C02 to develop actuators for at-sea rearm VLS to enable an advanced Mark 41 rearmament system to allow reloading naval vessels away from port facilities and without long transits. Tesar Power was used to develop an actuator prototype allowing replacement of the lowering hydraulics with an auxiliary EMA using a 24-volt brushed DC motor for its prime mover. The speed of the lowering actuator also allows completion of lowering the panels much faster than the 2-minute per panel time limit for task. The low operational voltage suits the nature of available emergency power in the form of battery power supplies. If an electrically powered decoupling actuator is fitted to the EMA crank arm, the hydraulic emergency system can be eliminated from the JBD mechanism, removing all its fire safety hazards and maintenance requirements. Redundant mechanical input allows sailors to operate the lowering system with electric drills, and drivers or hand tools in the event of battery power failure. Full electrical control could enable the fully remote operation of the JBD lowering actuator, reducing the crew required from 4 to 2 sailors for typical emergency operations. Tesar Power is not a single application technology, it's a platform, and our transition strategy reflects that. The primary near-term path is through the JBD emergency lowering actuator we've been discussing. We're working directly with PEO carriers on the testing and qualification milestones needed to integrate this actuator into CVN 78 class operations. This is our beachhead, and it's a credible one because we're already in the Phase 2 Option 1 contract. The second near-term path is the JBD declutching actuator. This is the piece that completes the picture. It eliminates the need for the hydraulic emergency lowering system entirely. Together, these two actuators replace a complex hydraulic system with a simpler all-electric solution. As we look further down our product roadmap, at the beginning of 2026, Fathom5 was awarded the Catapult Challenge, which brings Tesar Power to at-sea reload of the Mk-41 vertical launch system. This widens our customer base and use case and attacks a critical operational gap that Navy has been seeking to address for years. Lastly, Fathom5 has been requested to participate in the future ship design of SSN-X. Hydraulic systems are being designed out from the start, and Tesar Power's proven capability is being evaluated as part of the actuator replacement. We are continuously searching for transition advocates and program partners at all levels and welcome a conversation with anyone about our transition targets. Let's take a step back now and give a bigger picture on where Tesar Power fits into the market. The DoD is our primary customer. The Navy alone operates thousands of actuated systems across its surface and subsurface fleet, from deck handling equipment and motor-operated valves to catches, doors, and weapon systems. Most of these still rely on hydraulics. Every one of them is a potential Tesar Power application. As described in the previous slide, we have multiple contracts today with the Navy that just begin to scratch the surface of DoD applications, and we see immediate opportunity with deck handling equipment where the weight, maintenance burden, and fluid management of hydraulics are a true pain point for the fleet. On the commercial side, the hydraulic replacement market is enormous. Maritime, material handling, and construction equipment all face the same trade-offs between hydraulic power and EMA simplicity. We are building industry partnerships now to pursue these markets in parallel with our Navy clients. What does a successful transition look like for Tesar Power, and what do we need to get there? We are actively engaged with the Navy and are working to build a formal testing and qualification roadmap. What we need now are the right government and industry partners to move through test and evaluation efficiently. For prime contractors and system integrators, if you're working on Navy vessels, we want to talk. Tesar Power is ready to widen our teaming arrangements and to expand our applications. For program offices, we are seeking a Phase 3 transition partner. Our Tesar Power is adaptable and ready to transition to the fleet. Bottom line, our technology works, the IP is protected, and we have a clear line of sight to the fleet. We're looking for the right partners to take on this journey. Thank you for your time. I hope we have given you a clear picture of what Tesar Power can do, where we are in development, and where we are headed. To summarize the question, if you work on high-force actuation challenges in naval systems, we want to hear from you. Please don't hesitate to reach out, and thank you again for the opportunity.